In this circuit, a capacitor and a push button are connected and used as timers to switch the flow of current and turn on the red and green of the bicolor LED. Parts for the circuit include one 9-volt battery, one power jack, two momentary PB&Os, one 25-volt 1000 microfarad capacitor, three 470 ohm resistors, one yellow LED indicating current flow, one bicolor LED indicating current direction, and the breadboard. After the prototype was made using those parts, a custom-made PCB plus a female barrel jack and case were handed out to attach them all together in a nice compact box. The two new main components of the circuit are the momentary tactile push button and the polarized electrolytic capacitor. When input is applied to the push button, the circuit closes and current flows. When the capacitor is used in the circuit, it charges up to around the source voltage, reducing the current and dimming the LED because the capacitor's resistance is increasing. Now that the capacitor is full of charge, it can light up an LED using the stored charge for a few seconds. In the capacitor visualizer, when input is applied to button 1, current flows clockwise from positive to negative, charging the capacitor and lighting, then dimming the red LED as the output. When the input is released, current flows counterclockwise from positive to negative of the capacitor, releasing its charge and lighting up the green and yellow LED for a brief moment as the output. When input is applied to button 2, current flows in this loop, which drains the capacitor's charge as the output. Finally, when input is applied to both buttons, current flows clockwise and fills the capacitor halfway. Then it switches to this alternate path and bypasses the capacitor, retaining the brightness of the red LED. Essentially, the capacitor visualizer is a great way to visualize the capacitor's use as a timer and a short-term power source.